This is Chapter 2 of Learning Web Design, which covers some of the technology underlying the web. As always, please read the chapter in addition to watching the video. The book contains details that are not covered in the videos. Many non-technical people confuse the web with the Internet. The Internet is a general-purpose platform for interconnecting lots of smaller networks. It's based on the TCP/IP stack architecture, which we'll cover in a little bit, which includes IP addresses and domain names, which you may have heard of if you've been around the web very long. The web is actually just one of many services that are delivered over the Internet. Others include things like email, video streaming, and file transfers. Each service has its own protocols that govern what the service does and how it is delivered. In order to make sense of this last bit about protocols, we will delve a bit deeper into networking terminology. A protocol is a set of operating rules for accomplishing a given task. There are lots of protocols that have nothing to do with networking. For example, you're supposed to not show your fanny when you see the Queen of England for an audience. Network protocols stack on top of each other, with each layer of the stack interacting only with those above and below it. The result is to future-proof the network. We can swap in and out protocols as technology evolves. This is what allows Netflix, for example, to stream video faster than can be done over the web. To see how a network stack works, let's apply standard networking terms to the U.S. Postal Service, which has delivered first-class mail for over 2 centuries. Here we have a friendly grandmother sending a letter to her favorite teenage pop star. She starts the process in the application layer by writing a letter. She signs it to verify that it really is from her. Then in the transport layer, she places the letter in an envelope. In the network layer, she addresses the envelope and attaches a stamp. Finally, in the data link layer, she puts the envelope in a mailbox for pickup. This is where the network takes over. The postal carrier collects the letter and brings it to a sorting center for handling. At the sorting center, the envelope is scanned, routed, and shipped to its destination. This sorting, routing, and shipment process may be repeated several times before the letter appears at the destination, where the recipient retrieves the letter from the mailbox, reads the address, opens the envelope, and reads the letter. With that out of the way, we can now say something meaningful about the architecture of the web. The web is a client-server system in which all messages take one of 2 forms. Browsers issue requests to servers to execute commands, and servers respond by sending back the results of the command as content with added metadata to describe it. Thus the web is really just a collection of application protocols that operate over the Internet. HTTP and HTTPS are used to send and receive requests and response messages. HTML, CSS, etc. are then used to package up the content for handling by the browser. To see how the web protocols work with standard Internet protocols to send and receive content, let's consider the case where someone in his or her dorm room clicks on a link on the Fairfield University website. The browser uses Hypertext Transfer Protocol, or HTTP, to form a request for the page. Transmission Control Protocol, which is built into the operating system, breaks the request into smaller chunks called packets. Each packet is numbered for reassembly at the destination. Each packet is addressed for routing to the destination in the Internet Protocol layer, where it is received and combined with other packets before being delivered to the web server. A similar process works in reverse for the web server's response back to the browser. Let's watch HTTP play this out for a real web page, the one shown on the right. Because HTTP is just a messaging protocol, we don't actually need a web browser to use it. Here I am using Telnet, a piece of software that predates the web by 20 years, to access the web server and then type in HTTP commands to retrieve the page. Yes, the whole thing is happening in text. Everything was text back in the 1970s. For things like pictures, we'll need a web browser to view them, but we can retrieve them like any other file using HTTP. Here is an example from the book of how this works. The page is actually composed of 4 different files. The first is an HTML file that defines the content and structure of the page. Then there are 2 image files that are requested after the HTML file. The browser knows that they are needed by reading the HTML source, which tells where to find them. Lastly, there is a style sheet, which tells the browser what the content is supposed to look like on the page. This process of requesting the HTML and then going back for any files referenced therein is repeated for every page load on the web. Here's a visualization of the process showing each step. Step 1. The browser issues a GET request for a page. Step 2. The server replies with an HTML document. Steps 3 and 4. The browser inspects the HTML document looking for linked resources and requests each resource from the server. While it is waiting for a response, it starts to build the page for display to the user. The server replies with a requested resource, which can be just about anything. In this case, it's an image file. The browser completes the page build when all the resources are available. If you watch very carefully, when a slow website is loading a page, you can actually see this process play out for yourself. In order for HTML to tell a web browser where to find files, we need a standard way of referring to any resource on the web. We call this reference a URL, or Universal Resource Locator. A URL has 4 basic parts. The first is the application protocol, which is almost always HTTP or HTTPS. The second part is the domain name, which indicates where to find the web server on the internet. The third part is the path, which tells the web server where to find the resource. You can imagine the path as specifying folders on a hard drive. Here we're asking for the samples folder, which is inside the 2011 folder. The last part is the document, which you can think of as a file name for now. In practice, we can often leave off the document, letting the web server figure out what we want just from the path. So how does the web server know what document to load if we don't tell it? It uses a set of rules telling it default behavior for these sorts of things. Usually the web server looks for a file called index.html. If the server finds that, then it just returns the file. Why index.html? Because when the web was first conceived, everything was just files, and the index of a folder just said what files were in it. Other names are used that follow the same basic logic sometimes. So, for example, if you request the home page for fame.fairfield.edu, the server actually executes some commands in a file called index.php. With all this talk about locations and addresses, now would seem like a good time to bring up a margin note in the book about intranets and extranets. Just as every house lies within some sort of neighborhood, every device on the internet is on a local network with its own router to connect it to the wider internet. Each router, in turn, has the ability to assign its own internal addresses to any device within its local network. This address will only work on the local network and not on the wider internet. For example, when accessed from my home in town, the fame.fairfield.edu server is located at the address 192.160.243.35. However, when accessed from my office on campus, the server is at the address 10.13.5.15. The result of this internal-external separation is that the router can firewall the local network from the rest of the internet. Internets are just servers and other devices that can be accessed only within the firewall. Extranets, in turn, are how the router allows selected devices from outside the local network, outside the firewall, to gain access, typically by connecting to a proxy server at the edge of the firewall. We'll conclude with a bit about HTML and CSS, which together form the basis for the rest of the book. You can find HTML and CSS in any web browser. In Chrome or Firefox, all you have to do is right-click on a page and ask to inspect element to see the exact HTML and CSS that corresponds to any given item on the page. We'll come back to this really convenient trick later in the course. For now, you might want to inspect a few of your favorite pages to see how they're coded in HTML and CSS. HTML is at heart a very simple language, with a bare minimum of syntax rules governing its grammar. Its purpose is to define the structure of the page, providing organization to its contents. Just as how a physical object is composed of atoms, every page is composed of elements. Similar to how the periodic table gives names to the chemical elements found in nature, HTML has a relatively small collection of standard elements that go by names like HTML, head, body, header, and footer. Each element is written using tags, which always include the element name and are enclosed in angle brackets. Most tags appear in pairs, with one tag indicating the start of an element and another tag used to close it. For example, the HTML element starts with an HTML tag and ends with an HTML end tag. Note that end tags always include a slash before the element name. Whatever is between the start tag and the end tag is considered the contents of the element. This allows the elements to contain other elements, breaking up pages block by block, section by section. Cascading style sheets, or CSS, tell the browser what the page looks like and sometimes how it behaves. CSS works by giving a set of rules that can be applied to any or all elements of the page. For example, we can use a rule to indicate the indentation of every paragraph on a page by applying a rule to all the P elements found in the HTML. Thank you for following along with Chapter 2 of Learning Web Design. See you later.